Welcome to Mathema by RC YouTube channel. This is our 9th class of class 10 real number. In this class, we discuss two important theorems of rational number and irrational number, that is the relationship between decimal expansion and the rational number and irrational number. Let us consider here some rational number in decimal expansion form. Then we take some numbers and we simplify this number in p by q form. Okay, so when we omit this decimal, we get 1 0 0 0. That means here we get 375. When we factorize this 375, we get here it is divisible by 5. So here when we take 5, 7 5s are 35, 5 5s are 25, and again we get it is by 5, 5 1s are 5, therefore 15, 5, this is called 3. So here we get 3 into 5 cube. Also when we take this number 100 into 100 in 10 into 10 into 10, that means here we get 3 into 5 cube, that means 2 cube and 5 cube. So 5 cube cross, therefore we get 3 by 2 cube. Okay, similarly here we take the second number, suppose 0.104, therefore when we omit this number we get 1 0 0 0. That means here this is called 2 cube and 5 cube, and we take this number as a 104, therefore it is divisible by 2. So it is 5, okay, 5 and 2, then it is also divisible by 2, therefore it is we get 26. It is divisible by 2, this is called 13. So this is 2 cube and into 13, therefore it is crossed by 2 cube, it is gets 13 by 5 cube. Similarly we can also take 3 and 4, but we go to our theorem. Here the denominator comes from 2 cube and 5 cube. Since here all the decimal expansion which are the terminate, this is called the terminate decimal expansion. In this previous class we discussed three type of decimal expansion of rational and irrational number. This is called terminating, non-terminating recurring, and non-terminating non-recurring. Okay, in this previous class, in class 9 we also know. So x be a rational number whose decimal expansion terminates, that means the example of 4 example terminates, and x can be expressed as p by q, where p q are coprimes. That means p q are coprimes, they have no common term, either 1. Okay, and the prime factorization of q is in the form 2 to the power n, 5 to the power m, where mn are non-zero integers. So when we transform or replace the numbers of decimal expansion or decimal expansion of the rational numbers, terminating rational numbers, we get two numbers p and q, where pq are coprimes and q can be represented as 2 to the power n and 5 to the power m, where mn are non-zero numbers. Okay, these are the theorems, because when we simplify 10 we get 2 into 5. So this is the form of numbers of terminating rational numbers. Again, when x equal to p by q be rational numbers, such that prime factorization of q is in the form 2 to the power n and 5 to the power m, where m and are non-zero integers, then x has a decimal expansion which terminates. Okay. In this is the previous part of this theorem. Here we get this is a rational number whose decimal expansion as in the p by q form, where p, q are coprimes. Then the prime factorization of q, b is in the form 2 to the power m and 2 to the power n, or 2 to the power n and 5 to the power m, where m n are the non-zero integers. But let x equal to p by q be a rational number, and the prime factorization of q is in the form 2 to the power m, 2 to the power n, where n are integers, then it is terminates. Okay. Again, here we get an example from your NCERT books. 1 by 7, when we divide 1 by 7, we get this form. That means 1, first we since 1 is smaller than 7, then we take decimal point. Okay, so there is 0, so 7 we divide by 1, the 7, then we get remainder 3, then and corresponding way. So there is a loop, there is a terminating and recurring part. Okay, this is an recurring part. Sorry, this is not an recurring part. Okay, so these are the part. Here we get PQ, where we can also seen in this previous class. Here these are the part. So here x equal to p by q, where q are the coprimes, be a rational number such that the prime factorization q is not in the form 2 to the power m and 2 to the power n. That means the 7 we cannot represent in the 2 to the power m and 2 to the power n. Okay, since it is not multiple by 10. Okay, where m n are the non-zero integers, then x is a decimal expansion. This is called non-terminating repeating, recurring. We say here it is an recurring decimal point. Here we also get 4, 2, 8, 5, 7, then 1, and this is a similar process. There is a circular part. Okay, 1, 4, 2, 8, 5, 7, continuous this, and this is called the non-terminating recurring. So if we take p by q form, here p 1 by 7, here p equal to 1. Okay, p equal to 1 and q equal to 7, and when we pq are coprimes, when we cannot represent q in this 2 to the power m and 5 to the power n form, where m n are non-zero integers, then the x, the rational number of decimal expansion, are non-terminating repeating, that means recurring. From the above discussion, we conclude that the decimal expansion of every rational number is either terminating or non-terminating repeating. In this class of 9, we discussed this. Okay, if you cannot remember this class of your previous class, you go to our YouTube channel, go to our playlist and see the class of 9. Okay, when it is non-terminating, non-recurring, okay, this is called the irrational numbers. Irrational number, suppose root 2, suppose pi. These numbers are non-terminating, non-recurring. When we decimal these numbers, decimal point of these numbers, you can also see here the part we try to see in this 9th class. Please stay with us. In 2 seconds we can represent here the class 9. Okay, here we can see that the terms non-terminating, recurring. Okay, this is the part here we discuss. You see that here the term, this is called non-terminating, non-recurring. It is an irrational number. The root 2 and pi, this is non-terminating and non-recurring. Okay, pi not equal to 22/7. This is the near about, approximate value is 22/7, but the actual value of pi equal to 3.14159265358979323 and order continuous one. So these are the class. If you like this class, please tick the bell like and comment here. Also share with your friends. Subscribe our YouTube channel. Join in our Telegram group. In the description box you get the link of this Telegram group. Thank you. Stay with us, and the next class we will also see in this part. Okay, thank you.